Hi folks, I am solving Leetcode's top 150 questions and that's all you need for your coding interviews. So in this video, we'll be solving 703 kth largest element in a stream. You can read more about the problem statement, but we will start from here. Our task is to implement a class which for a given integer k contains the stream of text scores and returns the kth highest test score after new score have been submitted. We have to implement a class called kth largest which takes two input parameters, one the kth element and then the array of integers. And on every add operation on this, we have to return the kth largest elements. So for example, if you can see here, we are given this 4, 5, and our k is 3. So that means we have to return the third largest element whenever we add some. For example, here you can see we are adding 3 to this. Then we have to return the third largest element on this array itself. So when we will add 3, it will be like this. So you can see this is like an unsorted array and we have to return the third largest element. This is the first largest element, this is the second largest, and this is the third largest element. So we have to return this thing. If you think about it, a brute force approach would be every time we add the element to this array, we can sort it. So it will be something like, and then we have to return the third largest element, which is this 4. But due to this sorting, our time complexity is n log n. And how many times this will happen? Let's just call it m times. M is nothing but the number of times we call this add function. So can we do better than this? The answer is yes. Let me clear this up. So we can use better data structure called min heap for this. And what that will do is adding the element to the heap would be log of n time complexity, where n will be the size of the heap. So if you think about it, do we actually need more elements than the top k? Because let's just say if we add 10, so our new min heap would be 5, 8 and 10. And let's just say if we add something like 1, then our heap will remain same. So what we can do is when we will be initializing our heap, so after adding the values to the heap, we can remove the elements out of it. One more advantage of using heap would be we always have to return the front element, and since our heap would be always the size of k, the operation to add element in our heap would be log of k, and this will be m times, like number of times we'll be calling our add function. So let's see how we can implement this. You can click on the link below to watch the next part. Thank you.